Everyone, I'm glad to be here at PostgresOpen. Today I will talk about upgrades and how we do at my company. It will be a feedback on a real experience. And first, a little bit about myself. I'm Julian Ryu. I'm a DBA since 2012. And I'm currently a tech lead in the database team at OVH since 2015. And I'm the author of PG Terminate. You can check this out on GitHub. In this talk, I will talk about some definitions to be on the same level of terms, what they mean. And I will place the context, what we manage. I will talk about updates and upgrades, then do some conclusion and what's next in the future. First, let's talk about some definitions. Postgres has a versioning policy, which is split in two parts. Starting from version 10, it's composed of a major version, which is here the version 11, and a minor version, which is here version 4. But it hasn't always been the case. Before version 10, it was split in two parts too, but the dots are not the same. The major version was here 9.6 and the minor 14. Major versions are released about once a year, and they provide very awesome new features, and they are supported for 5 years. And they change a lot of things internally, so it's very big changes. On the other side, the minor version inside the major versions are released about at least every 3 months. But it's not 3 months always. If there is a critical fix or patch, they are released as soon as possible. So it's very important. They include bug and security fixes. But they are considered minor versions. In this talk, I will talk about updates, but updates is the fact of installing a newer minor version, but we also refer to minor upgrades. An upgrade on the other side, which is a major upgrade, it's installing a newer major version. So now that we have all the terms required for this talk, we can talk about the context. So I work for OVH, which is the European leader of cloud providers. So if you want, we have different kind of products, which is we have public cloud, private cloud, bare metals, new products like Kubernetes, logs, metrics, and a lot of stuff. The common thing about all these products is they all rely on databases internally. Every single part of those products use a database, mainly Postgres and MySQL. So the perimeter we manage internally is we have around 60 clusters with 3,000 applications, and our users are our own developers. So there are internal teams talking directly with us. They represent about 700 people. And we have more or less 400 databases. We have Postgres, but also MySQL, and we share the same kind of clusters. We have one primary, one replica, and one second replica we use for backups. This topology is shared between MySQL and Postgres, and this is one cluster example. We have 60 of them around. So, updates. If we go on the Postgres website, we can read that we must use the latest minor version inside the major version. And it's considered more risky to not upgrade rather than upgrade. So, yeah, let's update all the things. So how do we do this? This method is very simple. You have to stop the service, install new binaries, and start the service. Simple, but there is some attention points to follow. First, you need to read the changelog, just in case, because it may break. Generally, it doesn't break, but it may break something you use. There is some downtime, because we need to stop and start the service on new binaries. It can be minimized or reduced by using some kind of pooler in front of the database. And for example, we can use PGWestar with pause and resume commands. On some write-intensive clusters, the simply stop and start the service may take a long time. So you can reduce this downtime by manually issue a checkpoint command to force the walls to be written in the data files and reduce the recovery time at the start. Or if something goes wrong and the downtime takes too much time, it could happen, prepare for a failover in extreme case. And if you use Patroni, we use it at OVH, put it on maintenance mode because it could trigger an unintended failover, and there is a maintenance mode to avoid that. So the initial state for the example is the following. We have two clusters with some bunch of nodes. The first cluster has the first node is the primary and the second is the second node. Doesn't matter. We use at OVH a tool called Cluster Shell. It's an event-driven open source Python library, but what you need to know is there is two binaries, clush and not set, and even if you want to go further, you can use the Python API. So basically, node set lets you organize your servers in groups. So we have all nodes. You can have the cluster you want, the role you want, whatever groups you want. You can combine two groups by inclusion, exclusions, and additions, and so on. And basically, we use those groups with the package manager to update the packages and let it stop and start the service for ourselves. And we use Debian. So we use apt-get update and apt-get upgrade. And it updates. So we go for backup first because the important things we have on backups, they don't handle application traffic. They are outside of production. So we can manage them whenever we want. There is no impact on applications. So we go them first. So we call the group backup. And it goes in parallel. So it updates the backup role. And OK, it's updated. And on a second time, we use the fan out option, which does one node at a time. So it goes like this. It takes the first cluster, the first node, update it, second node, the third node, and the fourth node. And no matter the role, because we don't know if it's a primary or a replica, it goes one by one. It's very simple. And the final state, everything is up to date. But this is very, very simple. It may not fulfill your requirements. For example, you may need to update the primary or a replica and have some kind of logic in front of this and extend this tool. So you need to know that Clutch is great for one-shot human simple operations. So it's very great for very small companies managing some servers with simple logic. But if you want to improve it, you have to use the Python API and invest some time and so on. At our scale, we have another stack to do this for a completely automated system, which is based on Postgres, Flask, Ansible, all Python libraries, and some internal systems, legacy systems. So that was a simple part. Updates are very simple. I encourage you to do this. It's very important to have the most up-to-date version in productions. For security and bug fixes is the reason. And upgrades. First, why do we need to upgrade? Yeah, some basic thing is its support is limited to 5 years. 5 years may seem to be long, but in fact it's quick. I've been at OVH for 4 years now, and it's like yesterday. So 5 years limited. So you need to upgrade to have support new minor versions and always secure cluster. There's some improvements on newer versions, like parallelism, optimizations, and some performances-oriented features. And brand new features, like tons of JSON functions, logical decoding, upsert, new authentication, better security, better features. So it's important to upgrade. So let's upgrade all the things. It's simple. Yeah, let's upgrade. The method we use is the following. We have the original cluster shared in split in two environments. The production environment, where everything happens, and development environment for our developer to work on the same data set as production, but on a separate system. So they don't break the production in life. They have their own environment. And we use ZFS snapshot to daily ingest data or restore data on new environment. So they use the same data on the same version in virtual machines here. So the method is here. We create a new cluster on the new version. We set up some kind of replication system, which is not always a strictly replication system, but it pulls the data from one cluster to another, and we will detail it in the slides. We remove the development host. We put the developers on a new development host on a new version, so they can give us feedbacks on the new version. And they are responsible of their application, so they are the better public to know what's wrong or what's good for them, or what breaks or not. So it's important for us to have their feedback. And once everything is okay, and we're sure nothing breaks, and we promote the new cluster, and we forward the production applications on the new cluster, and we drop the old cluster. This is globally the method we use for upgrading with a minimum downtime. This is the main goal for us. So we have used multiple methods. The first one we tried is the application. We use PGDump and PGWestar, PGUpgrade, and logical replication with PGLogical. So the application method. The idea was to, our developer manage their code base. They have a bunch of objects they manage with an ORM. They control what they manage. So the idea was, on the same time, they can write on both data stores and move on the second time old object to the new data store and switch over. This is the first idea. The pros are, developers are autonomous. We are, as a DBAs, we can focus on what we do every day, and they can focus on their migration process. There is no downtime. It's pretty good, and it's software independent. They can move from MySQL to Postgres, for example. But on the other side, every team has a different object management policy. So we have to reinvent this process for every team. So it takes a lot of time. It requires a single endpoint, or you will have inconsistencies, because writing on both data stores at the same time is not always a good idea. It's pretty much never a good idea. And it's not a developer priority. So it takes a lot of time, because why do they need to upgrade? They are paid to ship new features, and upgrades are not achieving their goals. So we are not on the top priority of their list. So in the end, it wasn't a good idea. We did it for one cluster and it took 2 years. So it's not a good idea. You could try, but I would not recommend it. The second idea was to use PGDump and PGWestar. It's the method is here. We set up the old cluster to read-only mode to avoid new writes and inconsistencies. We dump the old cluster with PGDump, every databases. We restore it with PGWestar, and we switch over. And the new cluster is able to handle new writes on the new version, and everybody is happy. The pros are, we are autonomous, so it doesn't take that much time to upgrade. We as a DBA team. It's very easy to set up, 2 commands to remember. And if you have a bad vacuum policy or something, and very legacy system or something, it can indirectly wipe the table and the index bloat. But it's pretty great for small databases, but if you have a very large databases, the larger your database is, or the longer downtime will be. So be careful with large databases with this method. In the end, it's pretty great. We used it for dozens of clusters, It's very simple to set up, and the downtime for some cluster was affordable, so we use this method successfully. PG upgrade. 2 years ago, I was at PostgresOpen in San Francisco, and there was a talk on upgrades, and basically it said that PG upgrade was safe. I come from the MySQL world, and the MySQL upgrade binary has a bad image. You know, it's not. You can feel that it's not pretty safe to use MySQL upgrade. So I thought it was the same with PG upgrade. So we tried it, and here's the method we used. We still have both clusters. On a new cluster, we install both versions of binaries, and in parallel, we set up streaming replication from old cluster to the new cluster in the old version. We turn the old cluster in read-only to avoid inconsistencies, and we run PG upgrade with hard links to reduce the downtime for a few seconds. And we update statistics in stage on a new cluster. We build the replications on a new cluster, and we switch over. So in image, it goes like this. We have on top the old cluster, which is running on 9.4 here. And we have the new cluster with 9.6 version. And on the node 4, which is the intermediate primary, we have both versions. And the streaming replication goes from the actual primary to the node 4 in 9.4 replica. And we use PG upgrade to promote it and rebuild. So PG upgrade promote and rebuild replication to set up the new cluster, and we switch over. We are still autonomous. It's pretty transparent for the developers. The downtime is short, no matter the size. We don't have some extension like PostGIS with a mix of versions. So our process is very simple. That's why we have a short downtime. And it's easy to set up, at least the first time. Because if you have to have an up-to-date replica, for example, to build the new development server and have every day the fresh data, you have to repeat the process. And it can be harder to do. So the first time is great, but you need to automate for the second, third, and more time. The cons are, but it's not very difficult. It requires multiple versions of binaries on the same host. Be sure to remove them at the end of the process or to clean that up. And the rebuild process to have up-to-date data can be complex to set up automatically. Statistics. We did a human mistakes. Yeah.
Did you have to have both versions on the intermediary primary, 9.4 and 9.6?
Because PG upgrade requires, the question is why do we have both versions on the same cluster? Because it's not on the same cluster all the nodes. It's only on the intermediate primary. And because PG upgrade requires both binaries to do its upgrade. Yeah. And statistics. If you run PG upgrade, please read the lines, because there is written clearly that you need to update statistics. And if you don't have automated this, you can make mistakes, and human error are pretty common if you don't have automation. And we did this error. We didn't have updated statistics. And here's what happened. As you can see on the graphs, The load average rise up from the upgrade, right after the upgrade. It was because statistics were not populated, and what we used to have very quick queries turned to dozens of very, very hard CPU consuming and IO consuming queries, and it all breaks down. It all broke down. And I don't know if you know this meme. It's called reality hits your heart, bro. So we were, oh man, the world crumbled up on our neck, and we had management, and everybody was on fire, and oh, what happened? Everything broke, and it turns out that this cluster was responsible of the billing system. So customers were not able to pay new services. So yeah, when it comes to money, you always have people on the neck. So be sure to update statistics. It's very important. There is a simple command you can use. It's vacuumdb or analyze in stages with a number of job you want, and it takes it's very quick. So be sure to run this. In conclusion, it's great. It works very great, and we upgraded from 9.2 to 9.4 using this version intensively because it's easy and it's safe. And on newer version, you can use the logical replication, and at OVH we use the PG logical part. It requires version 9.4 minimum. The logical replication itself doesn't replicate DDL, so the structure, some alters, drop, create, and so on, doesn't replicate, and sequences too. But PG logical adds some function to fix this problem. We used the synchronized sequence function, and we did not use replicate DDL command because we were able to stop the schema migration on our own because we are also responsible of them. So we have the control to stop them, to pause them, upgrade, and to resume them afterwards. So we did like this instead of using this function. The setup is it's a little bit longer. You have to set up a provider, install extension, set up nodes, replication set. You have to dump the schema. Providers is a source cluster, the original cluster, the one you have on production. And subscriber is the one replicating data. So on the second step, you have to dump the schema on provider, restore schema on subscriber, and set up subscriber to set up the logical replication. And wait for data to be in sync. Hopefully you won't have any errors, so it will be good. And set up the read-only mode, synchronize sequences, and switch over. There are quite some steps, but it's okay. We are still autonomous, so independent of a vast majority of tasks from the developer. There is a very short downtime, even on different major versions. It's the time of switchover, so a few seconds for us. And you can replicate only a subset of your original cluster. For example, if you want to upgrade only 1 or 2 databases in 20 databases, you can. But on the other side, the same pro can be accounted. For example, you have to repeat the previous process for each database. So we have 20 databases in average, or between 10 and 20 databases per cluster. So we have set up some automation to create this process. Sometimes it's hard to debug. Sometimes it fails without meaningful logs. For example, it says, oh, something went wrong and you need to reset up the replication. Okay, but why? You have to investigate a little bit more to find the original error message. It stores objects directly in the database. It's an extension, so our developers can see or can be bothered by some additional objects they are not used to see, but you can restrict with permission and you can easily avoid this. But secrets are stored in databases. You need to tell the nodes that other nodes are here with credentials, so if you dump and restore, they will be in there. So be careful with credentials. It requires a high level of locks. So when you declare all your tables, you put a high lock, and it can block some other locks you would put. Encoding might be the same. So if you want to move a SQL ASCII, for example, encoding database to the new TF8 to clean this up, it won't solve this problem because it uses a binary replication decoding plugin. So it's faster, so it requires the same encoding. And we had a single use case where we have a segmentation fault on the original cluster. We didn't reproduce the problem, so we can't get the feedback because we don't write the code dump and so on. So we prefer to use another solution on that case, but it's very rare, and we had it one time and we didn't reproduce it. So be careful using this. We had some deadlocks setting up the replication tables set. That's because some application had the great idea to set up some high locks when they don't need it. So if you don't need it, don't put high level of locks. Or if you really need it, be prepared to debug some deadlocks when you set up all the things. Sequences, be sure to update them because they are not replicated. If you don't do this, you will have duplicate keys. We had it. It's easily fixed, but don't forget it. And encoding must be the same. It's pretty clear in documentation. This is why we wanted to fix an encoding problem using this replication, but we didn't. It's not designed to. For the weird problem we had, it probably because we were not using the very last version of PG Logical. Maybe it's fixed on the very last, but it's a commercial version. I encourage you to use it. You will contribute to open source by using it, but by the lack of time and the management decision and the availability of other solutions, we did not use it. But in the future, when we will continue this process, maybe we'll upgrade on the commercial version. And if it doesn't work for you, maybe another solution will work. For example, the built-in logical replication in newer versions, or PG upgrade, PG dump, and PGWestar. There are a lot of solutions available. despite the fact we had some drawbacks, it's a very great product. We use it a lot. We use it because the downtime is pretty quick and it's very great. I encourage you to use it, and it's compatible with both versions, so use it. The timeline was to, on this context at OVH, we were on when I get on the team, we were on Postgres 9.2, which is not supported now, on Debian with it. We use the application method, pgdump and PGWestar and PGUpgrade because the logical replication is not supported. And we, after 2 years of trial and setup, and you need to know that upgrading is not the top priority and the only thing we do as a DBA. So it's we don't allow 1 month, for example, to upgrade all the things. We do it on the background. So it takes time to coordinate all the teams, and that's why we took 2 years to upgrade all the clusters. But at the end of the 2017, we had logical decoding available, so we use it to feed analytical clusters. So the goal was to use the logical decoding. And we have a newer version, a newer OS version. And starting from this point, we had logical recoding, so we can use pglogical to do all the rest. And when we had some small databases, we still use pgdump PGWestar because it still works. And when pglogical failed with this weird use case, we used PGUpgrade, and it was great. And currently, we have Postgres 9.6 with Debian storage, and we use Patroni for high availability. So we moved to a newer version with newer features and so on. So in conclusion, we have new features, we have a better stability, better performance because we use new versions, and it's always secure. But what's next? Because as you can see, we are right now in 9.6, and 9.6 will be soon, or in few years. It's not the very latest version. There are 2 major versions available, and at least a third in a few days or weeks. So we still have work to do. So the plan is to upgrade directly to Postgres 12 in the next step. So, and to Debian 10 at the same time, because we manage also the operating system. And as Postgres on our setup is more advanced right now in our production, we can push to move from MySQL to Postgres, because right now it's the most advanced database we have. I'm sure MySQL can be advanced, but right now at OVH, Postgres beats MySQL. So it's maybe time to push forward for Postgres. And to ease the process, we need to automate, because a lot of mistakes we did was due to human error. We forgot to run some commands, we forgot to run some things, and it broke. So automation is a thing. On an extra notes, from this experience and so more, we have set up high availability, and we manage database on a daily basis. We are starting a new service, mainly in Europe and Canada, not for US right now, but we are starting a new database as a service for enterprises, which is based on performance. Reversibility, I know the cloud providers right now is not a priority, but it's priority for us. The goal is to be able to get in and get out as easily as you can, because we don't want to be locked in on the software. We want to be part of your journey, but not at all cost. It's managed. We do other things. Highly available. It's pretty standard right now. Elastics, and we use it for our own needs. So we are our first consumers. So if you want to test, we will soon launch it, but right now it's in testing phase. So you can check this out. There is a link below. So if you're interested. And we also are hiring, so if the challenges we faced interest you, you may have been around for 2 days, so you might check this out with me. And we mainly hire open source database engineer, but a lot more. Maybe we have a US-based company, so you should be able to go there. If you have any question, I would be glad to answer.
I do have one question. You said in the logical doing upgrades with PGLogical that you couldn't do encoding changes on that.
Yeah.
I'm not doubting it. I was just a little surprised. I mean, is that even with the built-in logical replication and canon on, or is that only with the older PGLogical?
The question is I've said that there are some encoding issues between, if you have mismatch between encoding. Is it specific to PGLogical, or is it also included in the built-in replication? My answer is we didn't use built-in logical replication. We don't have any experience with it because we are still on 9.6 and we don't have much experience with newer versions. So maybe in the next weeks or so we will try it and maybe we'll be able to answer. Yeah.
I'm not sure why it would be different, but I'm also not sure exactly why it doesn't work in the first place. It seems like these are basically transforming things from the wall into SQL statements, which are then executed. So you figure the encoding there would somehow be working. If it doesn't, that's a little bit disappointing.
The remark is it could be disappointing to see these encoding issues. The fact is we had them directly in the error logs. So the decoding plugin was returning there is some decoding problems due to encoding. So because it's PGLogical uses a binary decoding plugin, and on weird case in our database, it depends a lot on your data, and we had some data that wasn't greatly encoded or like this because we manage European data and we feed MySQL data to Postgres. So we have a mix of data stores and data coming to Postgres, where in SQL ASCII to simply ignore the encoding issues. And there was some dirty data in the original data store we couldn't identify. So yeah. Yes?
You talked about logical having a pretty short downtime, but essentially when you are synchronizing sequences, you can't write to the master, right?
Yes.
How long is it like?
The question is we have a minimal downtime and how long does it take to synchronize sequences? For us, it's a matter of seconds, maybe microseconds. Time to go through all the sequences and set it to the new value, and the next value will be usable, and it's pretty short. If you don't have thousands of sequences, of course. Yeah.
Even 1,000 should be.
Even 1,000 should be
Just
short.
updating one row in a table to update the sequence is really, really quick.
But if you have hundreds of thousands of sequences, because you have hundreds of thousand tables, we have it on MySQL. I don't know how Postgres handles this, but it could be a problem. Yes?
Did you have any case where you had a really large table that was quite busy with PGWestar and you ran into problems after some amount of time?
The question is do we had some problem with very large busy tables using logical replication? We didn't notice the size of the table was a problem, only the level of lock we had. So big tables were transparent to sync. We didn't have a problem syncing them. Even with hundreds of gigabytes, we don't have terabytes size table. So maybe this is because we don't have problem. Yeah. Yes?
So what method of migration will you use going forward when you migrate to 12, on 80% of the servers?
The first, we will try the built-in replication. We don't have experience. It's time to sorry, the question is, what method we will prefer for migrating to 12? We will try at first the built-in replication because it will be compatible. We don't have experience, so we will learn this and maybe share the experience.
Streaming replication?
No, the built-in logical replication. Yeah, because you can't use streaming replication between two different major versions. Yeah. So you have to use some logical replication or any other method. I'll go for the built-in replication, which is part of the core right now. If it doesn't work, still use PG logical. If it doesn't work, PG dump or PG upgrade. And for very small databases, PG dump and PG restore is a very, very good method. So maybe sometimes the complexity, it's not great to have a very complex system, or if you automate it and it becomes simple, it's great, but maybe sometimes you're doing the simple thing that works is great. Yeah. Any question?